Hello everyone, welcome to this video on ThreeSum. This is a Leetcode problem, and today we're going to try to figure out how to solve this Leetcode problem. So the main idea behind these lessons is to sort of teach how to solve these problems using the Feynman technique. I've already solved this problem, and what I want to do is I want to try it again and try to simplify and explain as if I was teaching it to someone who's never seen this problem before, and try to fill in the gaps between my knowledge and try to re-simplify if I find gaps in my knowledge. So this is essentially the learning technique I'll be using when I'm solving these algorithm problems. So let's begin. ThreeSum, Leetcode number 77. So let's say you were given an array of numbers. Let's say -4, -1, 0, -1, and 2. You want to return a list of numbers which has the subsets summing up to 0 for each element of the returned list. So for example, you would have something like -1, -1, and 2. These three numbers sum to 0. You would have something like -4, -4, let's add one more number to this for now. You have something like 2, 2, -4. And you can have something like -1, 0, and 1. So as you can see, these would be example of three numbers that sum to 0, and we will just return a list containing these three sublists. So one approach that you can take for solving this problem is you can ask yourself, well, we know that you have these array. What techniques could we think of to solve this problem? Well, ask yourself, can you use a data structure? Well, yeah, you can use a data structure to help you solve this problem. Let's say you were to use a hash map, for example. You were to use a map or a set to even store each number in the array, and then you were to try to get the x plus y equals z value for the number. You can somehow in n squared time find the two numbers which sums to the third number in the set, and then that would give you and then do that for each number in the list. So you could probably solve that in n squared time, right? And you'd have that extra space complexity for solving the problem. But what if instead you look at this problem and you ask yourself, okay, what other techniques can I use to solve this? What if we sort this problem? So you have something instead which looks like this: -1, -4, -1, -1, 0, 1, 2, and 2. Right, so you have this sorted list, and you want to ask yourself now, well, what can I do, given that it's sorted well? Well, can you somehow use, you're looking for three numbers, right? So you want the full range of numbers that can possibly give you three numbers that sums up to 0. So what if you were to put, let's say, a pointer here. Let's say this was slow, fast, and let's call it mid, right? And you would ask yourself a question, well, what if you were to take slow, fast, and mid, calculate the sum for now, and say -4 plus -1 plus 2. And you recognize that, well, this sums to be -2. No, this sums to be -3, right? So that is not 0. So what should you do? Well, you should move mid, right? Because we want to check each range of numbers. So we move mid up, and then you check again, right? So you do another check. You check a -4, but instead of you also have -1 again, and you do the same thing, and then you have 0, and you're sort of getting close, and then you have -2, and then you have 1, and then you finally reach 2, and then there you go. You finally have 0. So you store the subset in the array, and you store the subset in the array, and then you try to find out the subsets, right? So what you do, well, first thing you can try doing is you want to move the slope pointer up. Let's say you move the slope pointer up, and then you check again to see if you can find any other numbers that sum up to be 0. And after you do that, well, you've already checked everything from the slope pointer. Well, what if you push the fast pointer back? You want to check everything from the fast pointer and check everything in the middle. So you're sort of shrinking the window that you have for calculating 3 numbers that sum to be 0. And you're doing this because you have a sorted array, which provides you the opportunity to take advantage of the range of numbers that can sum to 0. So, well, what can you do? Well, you can take advantage of these numbers. We can start right now algorithms. Now that we have the general idea, we can start right now an algorithm for solving the problem. So we know that we need to sort. So sort nums. Well, we want to put 2 pointers. So we have slow at nums at 0, and then we can have fast at nums at len -1. Well, now that we have it there, what if we then simply start a iteration for mid? So start mid at slow +1, and then we can start, so for mid being less than and fast, we want to check this sum, which is num is slow plus n at fast plus n at mid. We check if num is equal to 0. Well, if num is equal to 0, well, what should we do? Well, if num is equal to 0, then we want to have a situation where we simply create a list num at s plus fast plus mid. We do that, and that's great. We can do that for mid. Well, how do we move slow and fast? Well, what we want to do is we want to iterate for slow, right? So we want to move all the numbers for slow and fast. So for each for slow being less than fast. We want to do this for mid being less than fast. We want to have and after you do this for mid being less than fast, we want to decrement fast. So we want to do fast -1, and then we want to do it for mid being less than fast again. Essentially, we want to do the same repeated algorithm, but after just pushing back fast a little bit. Essentially, we have an algorithm that runs in O(n) because we do this up until, actually no, we have an algorithm that runs for n divided by 2, right? Because slow is going to run for half of the array, and then fast is going to run for the other half of the array. So this runs in n divided by 2. This will run in however many iterations are in between fast and slow. So it will run in n. So it will run in n divided by 2 times n. So this will run in n divided by 2. N divided by 2 times n, and that will be O(n) squared. It just doesn't use extra space. So that would be the algorithm for solving the problem. So let's begin by coding up the solution. So, but first let's run this against our use case. So let's say we have slow. Let's go back to this problem right here. We have slow. You have slow, you have fast, and you have mid, right? So you have slow, mid, and then you also have fast. So according to our problem, to our algorithm, we start off slow, and we start off mid, and we start off fast. Pointers. We see that slow is less than fast, so for mid being less than fast, we simply just do our summation check. We check if the number at slow, -4, plus negative number at fast, 2, plus -1. Check if it's equal to 0. Is it equal to 0? No. So we don't. So we move on to our next iteration. We go to next one, next one, next one. We see it's finally at 2 equal to 0. So what do we do? Well, since it's finally equal to 0, we simply add an array which contains each element at the current pointer's index to our list, and we then move on by decrementing fast. Or hold on, we first start off by decrementing fast. And then we start mid again. We reset mid. So mid should always be reset. And then we do the checks again. Well, we check if mid is less than fast. It is, so we do our checks, and then after that we go back to the outer for loop. We check if slow. Oh, we do that in the for loop, by the way. And then we go again. And then when we're done, we so essentially, I don't want to miss out on the opportunity. Right. So that is the way to go about it. So let's begin coding. So let's say we start by sorting our array. So we do arrays dot sort, and we sort nums. And then we start by declaring our pointers. Slow is equal to 0, fast is equal to nums dot length minus 1. And then we do mid. So after we're done with that, we want to do a loop for slow. So and then we want to do another for loop. So this is for the mid pointer. But nums at fast plus nums at mid. And we want to check if sum is equal to 0. Then we want to create a list. I'm going to create a list of integers. What do? Well, we have our list of integers. No, this will be our return list. What are you going to do? Well, sum is equal to 0. Sublist. And then what we want to do is we want to add and what we want to do now is we want to have to decrement fast. So now fast has been pushed back. So fast has been pushed back. And since fast has been pushed back, then you want to do our check for slow. So before we do that, let's just make sure that our code is error free. So arrays.sort, slow, fast, length -1, slow, mid. It's a list of integers. It's a new list of a list of integers. And now this loop here. Actually, it's fine if we just have slow equals 0. And fast, slow plus, mid equals slow plus 1, mid is less than fast, increment mid, sum, slow, fast, mid, sum is equal to 0. Then we simply have a sublist. We have a sublist where we add slow, fast, mid, and then we add the sublist. And then we decrement fast because we want to push it back. So now we want to do the same thing. Okay, so, well, what's your next step? Well, your next step is to literally just have the same check. since fast has been adjusted for. And then when you're done with your check, you want to finally return. We want to return this result, and that is the solution to our problem. What we want to do now is we want to double check our work to make sure we don't have any errors. So we have a list. We sorted out a list. We have fast, mid. We have our results. We loop through, and we this slope plus 1. Mid is less than fast. So this is where we did our check. For the sum, we have our sublist, and we added slow, fast in our resulting list. We implemented fast. Then we did again another check, and we simply summed up our list. Our sublist, we added the results, and then when we're done, we simply returned the list. So that's how we solved our problem. Thank you again, and I hope this kind of gave you an idea of sort of a technique that's widely used applied to algorithms, and should be seeing more videos like this. I hope you like and subscribe, and yeah, have a good day. Enjoy yourself, and remember, take it slowly. Practice makes perfect.